I think we can start in a few minutes. Okay, I think we're basically good to start. I'll wait one more minute. Also, there was an issue with the links we sent out for the class. I think it
Why is the
automatically.
default name like Yanda Bao Instructor?
Yeah, I think that's just a glitch with the link we sent out. Sorry about that. You have to, I think you can change your own name by going to like the three dots like on your screen. So I'll send out a new link after this class.
I
And
don't know how to change my name
okay, that's fine.
better.
Okay, so I think we're basically good to get started for now.
Do you have a Google Classroom?
Oh yeah, so if you guys want me to set up like a Google Classroom, I'll send out like an email later about it because you might want to, if you want, you can turn in your assignment there and you can also check the resources that I'll send out on that classroom. So, but for now, we'll just get started. I haven't set up the Google Classroom yet, but also, yeah, about the whole name thing, the Zoom links for some reason, they're tied to like they give you like an automatic name somehow. I think it's like different for each person. So either you have to find your own Zoom link that they sent you when you registered for the class, or we can just send out another one that's like that just gives you like a blank name or something. So, but yeah, the default names are pretty weird. Okay, so for now though, we'll just get started. Yes, there are two of them. Okay. There we go. Okay. So welcome to your second week, your second session of Introduction to Java. If you missed the first week, I can send out the slides again and as well as the recording for that. I believe I have it. So I'll put that on the Google Classroom and I'll send a link. I'll send an invite for you guys to join after this class. So just look out for that. If you're on the mailing list, I think most of you are, then you'll get it. If you're not, I think I'll provide my email later and you can email me about it. But yeah. So before we get into like all the actual content, is anyone looking forward to anything this weekend? Any events, sport games, tournaments, whatever you're looking forward to? Spring break? Okay. I have spring break next week, so unfortunate, but okay, I see a lot of nothings. Well, hopefully you find something fun this weekend, but if there's nothing much, then for now we can move on. Oh, you had spring break last week. Okay. Well, this is a continuation of last class, obviously. Today we'll be going over some more specific Java syntax, as I believe some of you had issues with that. And we'll also be doing more on the data types and variables, as well as an introduction to functions. Functions are slightly complicated, so we'll be spending a bit of next week on them as well. but I just wanted to introduce them and send out some resources that you can look into on your own. Okay, so basic syntax in Java. All the code in Java has to be inside of a class for it to actually run. Java is case sensitive, so that means that you have the commands and keywords in Java, whether or not you capitalize them, it does matter. You'll get an issue with the code. Your code won't run if your capitalization is off. And one another important thing that some of you may have had an issue with when you try to create your own Java program in your own file on your computer is that it wasn't running properly. It was telling you like, oh, like class not detected or something. So the issue with that, sometimes just make sure that your file name matches the class name, your public class name. If the name of the class and the file, they don't match, then you're gonna have issues with trying to run your code and compile it. And I'll show an example of that later. So also only the code with any Java program, any large project, or even just one file for a program, only the code inside of the main method is going to be actually looked at and executed first by the computer. That means that if you're missing the main method or you have issues with something in the main method, you're going to have issues with your program. So always include the main method. And like I said, I'll show an example of that in a sec. And lastly, another important thing is that all your identifiers have to be unique. So identifiers, by identifiers, I just mean the names that you give for your variables, your classes, things like that. And those things have to be unique. Otherwise, Java will give you issues because it doesn't know what you're looking at when you say, oh, like, let's print out cat. If you have cat as both an int that has a value of 5 and also a string with its name that's like, I don't know, James, then you're going to have issues. But yeah. So about statements, I believe that there was some confusion yesterday, not yesterday, last week. I forgot to mention because I thought that I could just have you guys copy down this statement. But one issue some of you had is that there was a syntax error, which just means that your spelling or your grammar was wrong in Java. So the beginning and end for your blocks of code, they always have to start and end with these curly brackets. So as you can see here, we know what's inside of the class because we have one set of curly brackets. We have one in the beginning here after art and one at the end. We also know what's inside of our main method because we tell it, oh, here's one curly bracket and here's the next one. It goes from here to here. That's the beginning to end of our main method. And everything inside is called a statement. And as you can see here, we have one statement, system.out.println hello world. And each statement in Java, it has to end with a semicolon, which is this little funny thing here. It's not a colon, semicolon, it's on the right side of your keyboard next to the L. Each statement has to end with it. Otherwise, Java doesn't know that the line is ending because a lot of the times you can actually have multiple lines for one statement. And Java only knows it's the end for that if it sees the semicolon. So be sure to add it. If you're missing it, your code won't work. Okay.
When I run my code, it gives an error, but then it runs for some reason.
Yeah, so Java will sometimes have these warnings for you. If your code.
Pretty sure this isn't even from Java though.
Okay, well, later when everyone's doing the practice, can you show me like what the issue is that you're having?
I'm pretty sure it's because I deleted my .zshrc file 2 years ago.
Oh, your what file?
My .zshrc in my home folder.
Oh, well, unless it's something wrong with the path. Well, you can just show me later. But yeah, for now, I think it's best to just move on. If you could, do show me later, and I'll remind you. Okay. So we'll have some questions. Here's some questions to go over the bit of content that we went over last week. So if you could, everyone just like for these three, put what kind of, according to naming convention, what things would you name these? Like Would it be a variable, a class, neither? What could you use this as a name? You have small cat, cats, and 24 dogs. So if you could put that in the chat, that'd be great. Okay, so I see someone said variable, someone said variable class and nothing. And someone also did ask, does the variable have numbers? So basically, like we said last week, yeah, exactly. So there is, when you're naming something, convention has it. Uh, like I said, Java is case sensitive. Just because you can name something, you can name a variable something doesn't mean you should. A lot of the times for your variables, you want to name them starting off with a lowercase letter. For example, the first one, small cat. This one works because small is not capitalized. It's a name for a variable. However, with classes, you want the name to be capitalized, like with cats, the C is capitalized. And one important thing to note is that you can't have a name start with a number in Java. So 24 dogs won't work for a class, either a class for or a variable. Java won't let you do that, and it's going to give you issues when you try to run the code. Okay, the second part, I don't expect you to remember every single keyword, but there are some that you will see a lot when you're doing Java programs. So if you could just put into the chat what you think is a keyword out of these four. There's only one keyword. And a keyword, like I said last week, it's just a word that you can't name something with because Java has kind of reserved these words for its own operations. It's basically said, oh, these words, whenever we see these words, we're going to do this, this, and this. And you can't use these as names because we think these words are special. So if you could, if you have any idea, just put like a guess of which one is a keyword. Yeah, okay. So someone said void. That is the correct answer. Void is the only keyword out of these four. Uh, hello is, I don't know why that would be a keyword, but hello is not a keyword. Printed, you might be confused a little bit with dot system.out.println, like we went over last week. But printed also isn't a keyword. It's we'll go over a bit more of why it's print line and all of that. And line also isn't a keyword. All of these are, the only keyword out of these four is void. So, okay. And then we have some more questions, review questions to go over the stuff we went over last week. And this one was set. Okay. We did do a bit about variables last week. So if you could, for the first question, if you have any idea, please type out like what the statement would need to be to declare a integer variable and also assign it the value of 16. Yeah, and if you have no idea, that's completely fine because to be honest, you do need to do a lot of practice with coding and you need to remember these things. And also, oh, someone did put in the chat int num equals to 16 with a semicolon. So that's great. Yeah, that is how you declare and assign an integer value to 16. Don't forget the semicolon at the end, like I've said. Also, the name, the identifier can be anything you want. So I forgot to specify that, you can name it whatever you want, but num is a good name for if you just want to say that this is a number. It helps you remember that. Okay, what if you wanted to print that variable you just created out? For example, Daniel put in the chat int num equals to 16. What would you do if you wanted to print 16 out by looking at that variable? I don't want you to just go and say, oh, system.out.println 16. So don't just do this. What would you do instead to print out the number that you see in this variable? Okay, so I just typed something in the chat. Don't just do that. We all know that gives you 16. But if you wanted to use that variable, how would you do it? Yeah, good. It's system.out.println num. So whenever Java sees the name of the variable in a print statement, it's going to say, oh, what is the value of this variable? And it's going to get it and print it out for you. This doesn't, if you just have num, it's not going to do anything, and it'll give you an issue because just the value doesn't actually do anything with the computer. And like I've said, coding is just giving a computer a list of instructions, right? So you've got to tell the computer to do something. In this case, it would be to print out the variable called num. Okay, and this one's a little bit more complicated, but how would you print out 16 with the message of 4 squared is in front of 16? Preferably try to use the variable that you created again. Yeah, that's great. So it's just system.out.println 4 squared is, and then plus num. So system.out.println, and then you have 4 squared is inside the parentheses, and then num inside a separate parentheses just right after it. I think that will give you an issue because there's two things there. It's 4 squared in needs to be within double quotes, like because that tells Java that it's a string, and also you have to add it onto num, or you have to add num onto it. And you would just do that with concatenation, which is in Java is just a plus sign. So you just add onto it. Yeah, it's a good idea though, because there are actually some coding languages and a lot of syntax that looks like that some ways. So it's a good idea, but the syntax, the language is a bit off. Okay. So we can move on to some more about data types and variables. You can actually declare multiple variables at once. So if you wanted to save some time and some lines in your coding, wanted to make it look cleaner, you can just do this to declare variables. So int a equals to 5, you're creating a variable of type integer, a equals to 5, and you're also doing int b equals to 7 and int c equals to 12. However, this is 3 lines of code, and I would hate to try to read this if I was trying to maintain the code or trying to understand what it was saying, because you don't need 3 lines here. You can just have one, which would just be the type integer int, and then a equals to 5, comma b equals to 7, comma c equals to 12. And this only works because all 3 of these are of the type int. This wouldn't work if you had one be int a, you had one be string b, and you had a third one be Boolean c. So this only works because all 3 are of the same type.
I have a question for the Java code thing. For some reason I installed it, but for some reason it says get the Java development kit.
Oh yeah. Were you here last week?
Yeah, no. We didn't have class last week.
Oh yeah, not last week. Sorry. Well, the last session. So 2 weeks ago. Sorry.
Yeah.
Yeah. So it's just like we talked about in the last session. You do have to download the JDK, which just stands for Java Development Kit. You don't have to worry about what's in it, but it basically allows you to run your code and write your code. If you don't have it, you can't do anything with Java, basically. And you also
But,
have
for
to
some reason, when
download.
I press run Java and it just doesn't work.
Wait,
Yeah,
when you
it's
installed
because
it, did you say yes for the terms and conditions or no for the terms and conditions?
yeah. So when you do install it, you do have to be like, yeah, I accept the terms and conditions. Like, install this onto my computer. Trust me, it's trustworthy. There's millions of people using it and programmers using it. So
Yeah, but I
don't worry.
use Red. Like I try to download it on Red Hat, but for some reason it's just letting me open a file, and then the next thing I know, nothing works.
Huh, that's weird. Can I
Like, it's
send
just
you
a
a
file, and then for some reason it just goes blank, and it goes files again. And I press open again, it's like no, and then I press open again, it's just like da-da-da, and then it just disappears.
Probably
oh
corrupted.
oh no. Well, how about this? I can send a video right now of what it's supposed to look like to download the JDK. And if you want, you can just look at that and see what you are missing, because I'm not quite sure what your issue is. If you want to show me, if you want to show me later, because I think this also has to do with your earlier issue of whatever your runtime issue was that like let you run the code but didn't work. I think it's like the same thing. It's caused by you not having the JDK. So let me just send the link of the video in the chat right now. And also, if you weren't here last week, I did send out an email after last class about
Yes,
downloading the
I
JDK.
looked at the email, but it didn't really help.
Oh, okay. Well, I can help you later with that. If you just want to like
Like
share
I
your
can still
screen, then I can help you.
like I can press the play button now, but nothing happens when I press play.
Okay. In a sec, we'll have like a practice thing, and then I can help you with your stuff. Also, I believe there's at least one of us that wasn't here last week, so I can also just talk about that stuff again in general. Okay. But for now, we can just move on because this is like a concept-based thing. We don't need to apply it just yet. Okay. So Java numbers. Numbers are just one type of primitive variables. It's a type of a variable because, like we've covered last week, when you create a variable, you have to tell Java what type the variable is. You have to tell Java whether it will be a number, a character, a Boolean, stuff like that. So Java numbers, there are many different smaller terms that fall under the umbrella of Java numbers. There's two types. You have integer type numbers, and you also have floating point type numbers. So integer types, if you do a lot of math, you will know that integers are whole numbers basically. And integer types, the smallest one is a byte. It's from -128 to 127. Short is from -32,768 to 32,767. And then you see that it just gets progressively bigger and bigger. And usually, unless you're doing some very like abstract, some very high up like calculation stuff, you won't have to use like a long, and most of the time you won't have numbers that go bigger than int if you're dealing with actual everyday stuff. But those types are there for you to store your numbers, especially if they get super big. And we'll also talk about why these numbers are the way they are. For example, you might be wondering, oh, like, why is it so weird? Why is it -128 to 127? And also, like, why is it like this instead of like -100 to 100? And we'll go over all of that in a sec. So those are the four types of integer types. I believe there's actually one more, but these are really all you need to know. And you can do math operations with any of these as long as you write the code properly. It's the same for all of these. So the second type of Java numbers is actually called floating point types. So what is a floating point type? Well, as you can see here, these are integers. These are whole numbers without decimal values. They are not fractional numbers. To get a decimal, you would need to use a floating point type. I forgot why they're called floating point types, but Java basically handles them differently
It's
from
called a
just normal
floating.
integers.
It's called a floating point because there's no set amount of like digits, and it could be like anything you want. So if you do like an int, you don't have to put a bunch of zeros at the end.
Yeah, so I like what you said about like there's no like set amount of digits. There are limits to both of these, but yeah, I do like what you said about that. And you'll notice that if you do operations with these, there will be a bunch of zeros at the end because it's a float or it's a double. I think doubles are different actually. There's only float gives you that, but there actually is a limit to both of these types. Float is, I think you had a good point about why they're called floating points, but there are limits. Float, I think it only goes up to like 8 decimal places, and double goes up to like 16 or like 20 something. I forgot, but basically these are decimals. You want to use these if you're dealing with decimal numbers, and most of the time I advise you to just use a double. It covers all your bases. There's basically no reason you would use a float over a double in most cases. Okay, so I think there's an example. Oh, well, before we get to any of that, does anyone have any idea of how these numbers are represented? I'm also asking of you a bit of like how computers work in general. You might have like read some books or seen some fun like graphic videos on like how computers actually work, like deep down, like how those like on and offs and electricity works. But does anyone have any idea of how these numbers are actually represented in the computer?
Ones and zeros.
Yeah, exactly. But do you know what that's called? Like,
Binary base 2.
yeah, exactly. So I think Brian also said base 2. So basically, these numbers are represented through a base 2 number. If you do math, it's also a mathematical concept. For example, decimal is base 10. So like, 1 through 9, 10 through 19, 10 through 99, 100. That's binary. It's base 10. This is base 2. It's also called binary code. And that's how numbers are represented in the computer. Like you said, it's ones and zeros. So this is an example of what a base 2 number would be, a binary code would be to represent a number. Usually when you set the type of the number that you have, you also set how long this binary code is. The longer the binary code, the bigger numbers you can have. And we'll get into the details of why in a sec. But ones and zeros, it's 1 and 0 because 1 represents an on and 0 represents an off. In the earliest days of computers, you had these massive machines, right, that had like these switches on and off, and you would do logic and calculations using these switches that would represent on and off, and they would represent numbers and also like multiplication and not and all of that stuff we'll be getting into. So that's why it's ones and zeros. And we still stick to that basic principle even today. Even quantum computers have a concept related to this. So it's ones and zeros basically. And does anyone know what this base 2 number, this binary code is in like decimal? If you know how to convert it.
It's really easy, but you kind of need like to write it down. But
Yeah, it's a lot easier if you write it down. So I'll give you a second. If you know how to do it, please do it.
yeah, and also the 2 zeros at the beginning is just complete garbage. You don't need that.
The 2 zeros at the beginning, usually if you just write a base 2 number, you wouldn't need that. I just wanted to put that there because a lot of the cases where you see the use of binary code has a set length, right? It'll be like, I think a byte is like 8 or like fixed binary digits.
A
So
bit is
there's a
1,
set
a
length.
byte is 8, and
I'm sorry, you cut out. Could you repeat that?
a bit is 1, and a byte is 8.
Right. Did you convert it?
What?
I'm sorry, you cut out. Also, Alan, don't worry about it. I will introduce all of like how to convert these numbers and what they mean in a sec. I just wanted to see if anyone already knew. I feel like some of us do know, but basically I'll just move on and I'll talk about how to actually do the operation. So if you look here, this is how you convert a binary code into an integer, a decimal. The binary code of 00111010, if we put that into, to convert it into decimal, we basically just start from the rightmost digit. We start from the 1 on the right here. And the way it works is you have 1, and then you have the power of 2 you have 2 to the power of 1, you have 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and just on and on. You can have it as long as you can store. And what you'll realize with this is that you can actually store any number in this configuration. With zeros and ones and these powers of 2, you can store any number. And the way that works is you just multiply the 1 or the 0 by whatever this power of 2 is. So for example, this first one is a 2 to the power of 0. Second is a 2 to the power of 1. This third one here is to the power of 2, and so on. So you have 1 times 1, 0 times 2, 1 times 4, 1 times 16, 1 times 32, and then the rest of zeros. So if you want to figure that out, that's 53. So did I do that correctly? Yeah, it is 53. Okay. So basically, this binary code is just what the computer uses to represent the number 53. And the reason I want you to know this is because, like I've said, when you store numbers, when this computer stores these numbers, these decimal numbers, there's a set length. So that's why there's a limit. And if you go back to the earlier slide of, okay, I have to go all the way back, but if you go back to the earlier slide, you'll notice that these are powers of 2. This is a power of 2, a power of 2, power of 2, power of 2. And the reason that the positive number isn't a power of 2 is because 0 is counted as part of the positive total numbers. So 128 is like 2 to the power of like 7. So and 127 is 1 less than 2 to the power of 7, but that's because 0 is included. So in total, you can store 256 numbers, different numbers in a byte. And that's all powers of 2. It's all based off that concept. So that's kind of why I wanted to introduce that. Also, this is very important in terms of just how computers work in general. And I'll talk a bit more about it as we go further. Practice, you might want to get some pen and pencil and paper for this, but if you could, try to translate these binary codes into decimal. Yeah, and one really good point is that you are supposed to do math for this. You can just write this down and do the math, but you don't have to code in binary. There's a reason that we have coding languages instead of just coding in binary. No human is good at, writing binary codes. So don't worry about all of that. I just want you to, like we discussed earlier, this is how you convert the binary codes into decimal. You have these powers of 2, and then you multiply them by either 0 or 1. So you have 1 times 1, 0 times 2, 1 times 4. Yeah, and here are the binary codes. So just try to convert these. It's completely fine if you don't know and why how to convert these. As you go further with just math and coding, you'll understand more. But yeah, so one reason I chose these numbers specifically is that you can notice some interesting patterns. If you're interested in math, programming is very suitable for you because it's a lot of math and a lot of cases, and you'll get better at math as you do more programming. But basically, you can notice some curious patterns, right? The second and third one is just, yeah, exactly. The third is the second one doubled. Oh, don't worry. I'm not that great at math either. Don't worry about that. You'll get better at math as you do programming, and you also don't need that strong of a foundation in math. So if you look at the second and third one, the third one is just the second one. I mean, the second one is just the third one doubled. Does anyone have any idea of why that is? Yeah, remove the zero. See, you're good at math. Because this is because the zero is bumping these ones into a higher power of 2. Basically, you're just multiplying these things by 2. No, it was a great guess. It's actually the reason because, and you'll see this with bitwise operators. You have no idea what that means. I mean, well, most of you probably won't, but this is a very useful concept if you want to do operations with dividing or multiplying by 2. So you can just add a zero to the end or take off like a digit from the end. So yes. Oh, that's a very long string of numbers. But yeah.
I just copy and pasted a bunch of ones like many times
Mm-hmm.
into like a binary decimal thing.
Okay, so, and then you also notice a peculiar pattern with the second and third one. So second and third one, you'll notice that the third and fourth one. The third one is 15, the fourth one is 16. Does anyone have an idea of why these two binary codes look so different, but then, why it's only one apart in decimal? Any more great guesses? Yeah, that's actually a very good attempt at explaining why this happens. I like how you use the word dominoing, but yeah, that's basically what happens here. If you look at the third and fourth one, my question was, why is it 15 and the fourth one 16? Why is it only one apart, but these two binary codes look so dissimilar? It's because if you look, the third one is 111, and that's ends up being 15 in decimal. But if you just add one more to it, because it can only be 0 or 1. If you add one more, it has to get shifted up 1. So the last digit here, this becomes a 0, and then 1 gets added to here, because this is just 2 times of this, right? So 1 gets added to here, this becomes a 0. 1 gets added to here, this becomes a 0. 1 gets added to here, this becomes a 0, and so on. So that's why this is 15, and then this is just 16. And you also notice that any power of 2 is just a 1 followed by a lot of zeros, because this whole concept of binary codes is based off powers of 2. Okay, great. We should probably move on. And here are the 2 other very commonly seen data types, primitive data types that you will see in Java. You have your Booleans, and then you also have your characters. So Booleans, like it states here, it's just a true or false. For example, a Boolean might be, is raining? Is it currently raining? Or is snowing? Is it currently snowing? And that will be true or false. Maybe it's hailing, and that's not either of them, but okay. And then you also have characters. It's another primitive data type. A character is, yes, false and false. I mean, it depends on where you live, but a character is a char, C-H-A-R. It's C-H-A-R in the actual code, and I'll show an example of that in a second. So a character is just a single character that's surrounded by single quotes. And you can also have ASCII for your characters, and I'll explain what that is in just a second. So here's an example of every single data type that we've talked about so far. The first one is int number equals to 5. So it's an integer, which is it's not the biggest integer type numbers, but it's also not the smallest. It's an integer int number equals to 5. You have a Boolean is fair, is life fair equals to false. So don't forget, you have to put a semicolon at the end of all of these. You also have char or char, however you want to pronounce it, equals to 65, but then also char equals to a in single quotes. So both of these actually work, and we'll get into why this one works. So obviously 65 isn't just one single character, but like a is, but it does work, and we'll explain that. And if you want to print this out, you can just see here, like we practiced earlier, you can just add a string onto it by saying this plus string plus this variable plus string plus variable. And then you'll have a is the same as also a. So actually, I should demonstrate this. So I'll share my screen. So if you take a look here, you have char a equals to 65, and then you have char also a equals to, and then it'll just be a. And then you can do so if you look here, we have one char a that's 65, one char also a is a single quotes. So this just equals to a. And then we can print this out. Also about I saw someone asked about the colors earlier. The colors, don't worry about that. That is, you can actually pick and choose which colors you want in combination with each other. I just used this one. A lot of people use the basic black one. So the numbers are just to help you more easily read your code. Okay, so we'll give that a go. Let's see what it prints. Look, A is the same as A. Oh, I guess 65 stands for capitalized A, but yeah, that's basically, you'll see that it doesn't print out 65. It prints out, I need to save this, but there we go. A is the same as A. So you see that 65 doesn't print out 65, it prints out a capitalized A because it's a char, it's not an int. If you change this to int, you would have a 65. And then if you just want to demonstrate that, look, 65 it isn't the same as A. This is because you change it to int. Okay, so back to the example. Here's just every single data type, all the primitive ones. Also, we mentioned a string last class. Strings, to simplify them, they're just collections of chars, of characters. So a string is just a list of chars. A string isn't its own primitive data type. So if you wanted to put here, you'll notice that string is capitalized. So string str. And I'll have an error here because it's, but look, so this is just a list of chars. Each one of these is its own individual char. H is a char, E is a char, and so on. So that's how chars work. Oh no, my light turned off. Okay, anyways. So moving on, this is the explanation for why characters can also be numbers. It is how computers represent these characters in its own operating. When it's operating, this is how it represents these characters. It represents them with numbers. So you'll see that 65 is just the decimal representation for the number capitalized A. 66 is B, 67 is C, and so on. They don't start at 0 because you have more symbols that come before it. I think like quotations come before it and all that stuff. And I'm pretty sure that lowercase characters come after uppercase. So I think lowercase a would start at 65 plus 25, which is like 80. It'd be like 80, no, it's 90, 91. So a lowercase a would probably be 90 or 91. And you'll see that once again, we see this concept of a binary code of a base 2 number. So that's how the computer is representing these decimals, which is then representing the symbol A, or you can just go straight from binary to A. The computer understands that. And you'll see that, and if you look at this one, this is just the binary representation of 65. You have 1 times 1 and 1 times 64. So that's just an ASCII table for you. You definitely do not have to memorize this table. Back when I first learned this, I thought that I had to memorize it. You don't have to deal with ASCII values unless you want to be working very closely with these strings and characters. Okay, so we've gotten to the harder part of the lesson, of the course. And before we move on, I just want to give about like 5 minutes. Does anyone have any questions or any thoughts, anything they want to ask about what we've done so far with these data types and binary and ASCII tables? Okay, so if there's no questions, then we can just move on, which I'm assuming you guys want to do. Okay, so this is the more difficult part of the actual lesson. It's functions and methods. So functions and methods, you'll hear them being called both of these, and they're basically the same thing. Functions are methods and methods are functions. There is a slight difference in the definition of them, but we don't have to worry about it yet because you won't know what it means even if I explain it. And so functions and methods, they contain blocks of code for you to call upon, and it runs when it's called, and it only runs when it's called. For example, you can write the code for a method, but then it won't actually do anything until you go into your main function, your main method, and call that method. And we'll go over how to do all of that in a sec. And also, these are reusable, which means that you can call them multiple times. It's not just one time, it's like a package, it's like a book basically that your computer is looking at. It's saying, oh, what's inside this book and what does it tell me to do? And it does all of that stuff in it when you tell it to. Okay, so we have already seen a function, and I kind of spoiled it on the last slide, but does anyone know what the function we've been using so far is called? Or method. Method, function, they're basically called the same thing. Does anyone have any ideas?
I don't know, I don't know much, Ollie.
Okay, so you might have heard me mention this earlier, but it's fine if you don't remember. Basically, your main function or main method. So if you look here, we had our public static void main, and you don't have to worry about what these 3 words mean yet. I will explain them in a second, but you have your main function, your main method, and that's what we've been using so far. That's what the computer runs when it's called. Okay, so it's the main function, and here is how you define and you make a new method, not just the main, because the main's all fine and well, but if you want to have everything in there, you're going to have a lot of issues with both your organization and also how efficient your computer is going to be. So methods 100% all the time have to be created inside of a class. You can't have a method outside of a class. That's simply not how it works. You could have one called a function like in Python outside of an object or class. But in Java, you always have to have a method inside of a class. Like if you look here, you'll see that our main method was inside of my class, public class, my class. Okay, so is there anything else? Oh yeah, so here is basically the structure of a method or function. You have some keywords in front. These are the words that, like I said earlier, Java reserves for itself. You can't name anything these keywords. These are sensitive words that reserved for cases like this. For example, we had void and public and static earlier. You don't know what they mean yet, and I will explain them. And then you have the name of the method in front of a normal parentheses, and then you have these curly brackets to show you where what the code is inside of this function or method. So what the statements are inside of this. So you have some keywords in front. You have the name of this method. So this could be like, oh, print my name, or oh, make a phone call to my friend, stuff like that. And then you have these parentheses, which you could sometimes put in stuff inside of, and we will go over that. And then you have statements. Okay, so here is an example. The keywords. First, we can look at the keywords, static and void. What does static mean? Well, it means that it belongs to this class. Like I said earlier, you have to declare these methods inside of a class, otherwise they will not work. Static means that it belongs to this class and not an object of this class. And we'll go over exactly what that means in a sec. But normally you just have static, void, and then something else. Most of the time, until we learn about classes, you will be using static in front of your methods. And void simply means that it has no return type. And we'll also be going over that later in this same session, unless we run out of time. So void just means that there is no return type. And print stuff, this is the name of the method. It's kind of a bad name. I advise you strongly to name your methods something better than print stuff, but I was running out of time, so I just named it this. And then here's your statement, right? So you have system.out.println. This method was called. Oh, look, I misspelled it. I accidentally capitalized was. But yeah, so this is exactly what it does. And I don't think I have it created so far, so I'll just go make it quickly right now. So you have static, void, print stuff, and then you have your parentheses, which you can sometimes put stuff inside of, and then you have your system.out.println. This method has been called. So here, you notice that there's an issue, there's a red underline. Whenever you see this inside of your editor, you know that you've done something wrong. And here we just simply misspelled it. It tells us that the token static, this doesn't mean anything. So delete the D and we'll be fine. It's static. So if you want to actually print something with it, we can just call it print stuff. That's how you call a method. You simply write the name followed by the parentheses, which sometimes contain stuff, sometimes not. In this case, they don't contain anything, and they shouldn't because there's nothing it says it needs to contain in here. And then you have your semicolon, and that's it. Look, so this method has been called. And if we take out this part where we call it, the same thing, nothing will happen because there's nothing in main. Like I've said, okay, that's because I didn't save it. There. Look, nothing happened. Oh, run again, there's nothing that's gonna come out. Nothing happened because there's nothing in main. So if we just put print stuff, it should fix it. Okay, back to the slides. Oh yeah, of course you can call this method multiple times. So it's reusable, as I've mentioned, and that means that print stuff, that's one of the strong parts about methods actually, is the fact that you can use it multiple times. Some of you know that there's things called loops that also let you do things repetitively and repeatedly multiple times, hundreds of thousands of times. But loops aren't the same as methods. And methods actually, a lot of the time, methods are used either within loops or methods will contain loops. And that's depending on what your code needs to do. But one important thing to keep in mind is that you can just call this method over and over again. So if you just say print stuff twice, it will do it twice. It gives us the same message twice. Method has been called, method has been called. Look, how cool is that? Okay, so with that out of the way, let's do some practice. I'll give you guys about 10 to 15 minutes. Create your own method, just name it whatever name you want. Put static void in front of it so that you have no issues. You can change it as you become a better programmer, but for now, static void is sufficient. And then just have the method prints out a few sentences about yourself. Don't forget that you have to call the method in the main method, in the main function, or in whatever this is, the main method, so that it actually gives you something. Like I showed you earlier, it doesn't give anything if you don't actually call it. So yeah, I'll give you guys about 10 to 15 minutes. And once you are done, you can, I guess, whoever is done can share the screen and just show me what they've done. So. Oh, by the way, sorry, you don't have to memorize the code syntax and the format and all of that. I just stopped sharing for a second because I had to change something about the slide. So here, let me just share my screen again, and you can just refer to that instead of having to memorize stuff because as of right now, you probably have nothing memorized because you haven't coded enough. After a certain point, you will have these things just kind of in your head. You'll know like what the basic method for printing something is and all of that. So let me just share my screen again. Sorry about that. And I'll give you guys about 5 or 10 more minutes. Yes, of course. The formatting, that's just the Java syntax, it's the language. And then what's actually inside is just being printed. That's so like obviously it doesn't depend on what you put inside of it. It does not need to say this method was called or anything like that. you can just write whatever it is about yourself. I just want you guys to practice typing this out and all of that. Right. Yeah. If you're still using JDoodle, it does look a lot different because you're just on this website that is letting you write your code there and test it out. JDoodle, you can't do a lot of the more higher level programming things with it, but it's good for beginners. And if you haven't gotten the JDK figured out or the editors, then just use JDoodle.
Okay, I did it.
Oh, that's great. Do you want to share your screen and show us like what you accomplished?
Sure. Okay, let me share my screen.
Does it not let you share screen? Okay, here.
It's okay.
Okay, there you go.
Let me share.
Nice. Okay, so, ooh, okay. Can you scroll down a little bit?
I have a bunch of them.
Okay. Can you run your code? Let's see if it works. Wow. That's great. Wow, yeah, it is April Fool's. Okay, that's great. One thing is that I would just suggest, especially if you're only calling them at once anyways and all in the same order, because this is a song lyric, you shouldn't be calling them in jumbled order. You can just reduce it to all just one function with a bunch of different print statements. You don't need functions. Maybe I should have been a little bit more clear, but functions can have a lot of statements. So you can all copy and paste this into one statement, you'll be fine. But yeah, other than that, good job. And I like this song. I like the choice of song. Okay. So, this is just what I came up with in terms of about me. Yeah, very cool. And then let's see. It gets called twice because print stuff gets called twice up here. But this method has been called. My name is Yanda. My name is 16. I mean, my age is 16. My grade is blah blah. And then on and on. So, unlike what you did, I just put all the print statements into one function here, especially because they're going to be going in the same order each time. There's not much point to putting them all in different ones. So yeah, methods are for containing blocks of code that you can use over and over again. So that's great. We are making a lot of good progress. And then we can basically move on from
There
here.
was a reason I decided to put a comment before public class, so you couldn't see like the line of code that said print. I would never gonna give you up.
Yeah, that's great. I know what you mean. But yeah, in case you didn't, in case anyone else didn't know that you could, be sure you realize that you can put multiple statements. And also, yeah, Brian, that would work. Would work, and I think, yeah, that looks good. It would print out 3-27. So how long is this class? This class goes until 9 o'clock. So yeah, we still have a bit more to cover. And I think that today, because we didn't get caught up as much on the practice and questions, I think we might end a couple minutes early, but I can also go over the return types, which is pretty important. And then I can introduce to you your homework / project. Okay, so good job with the whole methods thing. And now we can move on to variables and methods. Variables will only work inside the method if they are declared within the method. So this is something called scope, and we will discuss the scope of a variable a bit more in later weeks. And basically what you need to know is that if you look here, a variable will only actually work if it's within the proper method. So if you have, say, if you had int a equals to, a is a bad name, don't name things a, int num equals to 1, and then you wanted to do system dot out dot print line, and you want to have num here, this gives you an issue. You can't do this because num isn't a variable that it sees and it knows what it is, because num was declared and given a value for here. You said int num equals to 1, and then but then you wanted to look at it again. You wanted the computer to say, oh, like what is num, and then print that out. But then you did that in a separate method. You can't be doing things like that because it can't see the variable from this method. So yeah, there's an issue with that, and we can fix it pretty easily actually. This is called parameters. You can pass variables into the method. What does that look like? Well, like I said earlier, I might be repeating myself a little bit, but those parentheses, they're empty. But if you wanted to pass a variable in, you would be using those parentheses. So like I said earlier, this code gives you an issue. You have parameter equals to 20, and then you try to print it out, but the code inside my method doesn't know what parameter is. So that's going to give you an issue. How you would fix that is by doing something like this. You have, say, your main method, public static void main, and then you do your parameter. You say, oh, int the name is parameter equals to 20, and then you pass it into my method, and it would be static void my method, and then int value. So, and then it would print out this value. So you see that instead of just having instead of just calling, oh, what is parameter in here, you pass in value. You have value inside of this parentheses, and then it gives it to you, and then you can use it instead of that other method. However, you want to be careful because we only wrote my method to work if you pass in an int value. Instead of, if you call just my method with an empty parentheses instead of my method with an integer data type inside, it will give you an issue. It gives you an error. That doesn't work. So when calling a method, you have to give it all the parameters that it requires. I believe that this is actually called a signature, this method name and parameters requirements. So this is required. An int is required. And here we give it an int by giving it parameter. You can also just give this 20. You don't have to use a variable, but that's how it works. And you can, you might be confused, why is the name here different from up here? Parameter is different from value. Well, the name here does not have to match the name that's up here because the int here is just for you to use within your own method, within this new method. So because this is value, this has to be value. But because this is parameter, this doesn't have to also be parameter. So yeah. So let's do some practice. I want you to create variables in the main function for your name, age, and favorite color. You are going to have to use different data types for this, like a string, int, all of that stuff. So you're going to have to use different data types, and then you have to pass them into a method that uses print statements to print them out for you with some added text. For example, my name is, and then you would add on to that your name that you passed in. And then you could be like, my age is, and then you pass, and then you add on the age. So this is actually slightly complicated, and we can go over, I'll leave this up, and then we can go over this in a second and how to do it. And if you don't remember, the way to add these variables onto the string is just with a plus sign. Okay, I'm gonna stop sharing my screen for a second and I'll continue in just a second. I have to edit something on the next slide. By the way, I don't think you would need to go to your downloads again because it should have saved to whatever you set your whatever folder you were working with in, unless you were doing it online and then you accidentally just deleted the whole thing. That might be an issue, which is why I would advise you not to use an online editor. So, okay. So if that folder is within your downloads, then yeah, it's pretty quick to just go and check and see if you have it. If
I'm
not,
pretty,
it's fine. I'll go over what to do in a sec.
I'm pretty sure there's a shortcut to like redo what you accidentally deleted, like using a.
Yeah, you can Control Z it. So Control Z is the shortcut for
Yeah, but if you like
restoring
delete
it.
the tab, you can press Control Shift T.
Yeah, you can also do that, but editor websites usually won't keep what you typed in. So if you close the entire thing, then unfortunately, usually you do just lose it. So because Control Z is different from what the actual website provides. I believe Control Z it's like a cache thing. It basically doesn't keep it forever. Yeah, that's unfortunate. I think you do have to write it again. But is anyone done and would like to share? If not, then I can pull up what I have. Also, this is the wrong page. I'm so sorry. Here, this was the assignment. Is anyone done? Okay. So if no one's done, then I can just go over the basics of how to do it. You'll just basically you'll have an integer like age, and then it'll be like age is 12, and then you want to print out your age, you can just do your int value or int age, either one. It doesn't matter what you name it, but then you can just do add age because it's the same as here. And you can say my age is, and then if we save this and run it, it should work. My age is 12. Okay, nice, that works. Okay, wait, also I just realized I forgot to share the actual thing, so let me do that. This was just the code for it. I just typed it up really quickly. And so you see that we create a variable called age, assign it 12, and then we pass it into this method. So we gave it to print stuff, and then print stuff is like, oh, let's print out my age, and then you have your age. Great, that works. Okay. So I will go back to the last thing we have to cover today, which is so return statements. This is slightly complicated sometimes, but you basically have to return a value if the return type isn't void. For example, earlier we saw that static int, it was static void and then your method. Now it's static int and then your method name. So now that means that you have to return a type of something of type int. And what does it mean to return something? Well, returning is basically when you the method gives something back to the main method. For example, you have your int parameter and then you give it to your method, but then the method takes it. So it goes parameter, goes to method, method takes it, and then it gives it back to main. It returns it by adding 10 to it. So it returns the parameter that you gave it plus 10. So does anyone know what they think that int result will equal? If you have 20, you give it to the method adds 10 to it, and then gives it back to you. What do you think the result will equal? Any ideas? Okay, so basically the result ends up being 30 because you have your parameter that you give to the method, add together, you pass in the parameter, and then it adds 10, it returns it. And because we set this equal to the method, the result is equal to 30. When you return something, it basically just replaces the method when you call it, it replaces it with the new return value. So a void method means that you are returning nothing. You can also have int, Boolean, and string methods that return to you an int, a Boolean, and a string. So it will give back to you an integer like 5, a Boolean, true or false. That's actually quite common. You will get Booleans and ints. String is slightly less common, just in terms of actually doing it, but a string, sometimes it will actually give you a string as well. So yeah, you have your int, Boolean, and string methods, and I can just demonstrate that really quickly, and then we'll basically be done for this week. And I will send out a homework with today's slides and as well as what your homework project is for next week. So let me show that. Okay, so you have your print stuff, and then what if you wanted to do, add together like we said earlier? So add together. You could have value. This might be equal to parameter 10, 12, 12, and then you would have your result. You would actually want this to just be the parameter because otherwise it would just give it 12. So it does all that. I have to change a bit here, but there, now everything's fixed. So it's just like within the slide, the parameter is 12. You give 12 to the add together method. Add together method takes it, adds 10 to it. And then as you can see, this is a keyword return. It returns it, and it's able to do that because it's a value of type int. And then you have your int result just equal to this value, your int value. So let's save this and run it. Oh wait, I didn't print anything out, so let me do that. System.out.println, and then you would want to print out your result. So here, there we go. You see how it went from 12 to 22? That's because we added 10 to it. So yeah, system.out.println, and then your result is 22. So that's basically the extent of what we have today. I will send out the slides along with the homework exercise you have either tonight or tomorrow morning. I'm sure all of you want to get some sleep because I'm sure it's late for some of you. So yeah. Thank you for coming to this week's session, and you are free to go. Be sure to check the email that I sent out, for like the follow-up. But yeah, good night, everybody.
Bye.